Hey guys, what is a black hole? So basically, that that's a good question. But let's talk about the origin first. The origin of a black hole comes from a supernova. That's an exploding star, and what ends up happening in a supernova. I have another separate video on this if you want more details. But you basically get a huge. The star expands to a really big size. It can't sustain itself, and then it collapses in on itself. And during that collapsation part, things get squeezed so tightly together, so densely together, that you end up getting a resultant black hole. Now, black holes are basically they're kind of like the enemy of space-time because they warp it so badly that nothing can escape from it, even if it was going the speed of light. That's why like not even light itself can escape from it, because light is the fastest thing. It goes at the speed of light, and so if you were trying to escape something, you want to go as fast as possible. So there's a lot of different properties of black holes. There are thousands of books written on it, like a lot of equations. So this is black holes was one of the areas that Stephen Hawking actually got famous for, because he talked about what's called the event horizon. That's kind of like the point of no return for a black hole. And he termed this term called like Hawking radiation, and that is radiation that actually comes out of a black hole. It has to do with quantum mechanics though, but we'll talk about that a little bit later. So a black hole basically means that nothing can return from it if it gets sucked into a black hole by its gravitational force. Now you'll notice though that in black holes you'll actually find like they represented by like a disk, but on the like polar ends of the black hole you actually have jets of energy streaming out, and that energy is actually coming from the black hole itself. Now one thing we should kind of like explain why black holes are even important to begin with is that they are actually what hold galaxies together. In the middle of every spiral galaxy, such as our Milky Way galaxy, there's a supermassive black hole. There are different sizes of black holes, so we call like the one in our center that holds everything together a supermassive black hole. That's why in the center of the galaxy, like there's actually a dark spot. That's because there's a black hole right there. And that black hole is really important because it actually allows everything to rotate around it. That's why you have like a spiral formation in the first place. So we actually probably wouldn't be here without black holes, believe it or not. Now they're back to that those jets of energy. That's actually very dangerous because the amount of energy coming out of there is extreme. It's like gamma ray type of material, which is the highest energy form on the electromagnetic radiation scale. Like we have, like light, ultraviolet, X rays, and then gamma rays. And so if one of those rays were pointed straight at Earth, I mean, we'd be obliterated. It's much, much more intense than the sun. So, good thing that we're like not in the path of that. But the odds of that actually happening are just so low that we don't even, worry about it. But black holes kind of help us explain like how galaxies can form in the first place. And they've been known as well to be like the causes of entropy. But not, I wouldn't say it's the cause, but they contribute to entropy itself. Like they're the greatest manifestation of entropy, because what ends up happening with black holes is that they take in organized matter. So organized matter has information in it. When you have an object, like such as a shirt, for example, that shirt the atoms in that shirt is organized in a certain order. But when it enters a black hole, that organization is unkept, and it then is shot out as energy through those two energy beams, if you want to call them, from the black hole. Now, what Hawking actually like uncovered was that that information isn't lost, and that the information itself is actually stored on the surface of the black hole. And I don't want to get into it because it's kind of it kind of needs a lot more explanation. But the whole point is that we still don't fully understand black holes. And another thing I should add is that there's kind of two camps of theories. There's the Einstein gravity theory, and that helps us explain the largest events, stars, how the world rotates around the sun, how galaxies form. But then there's also this field of quantum mechanics, which is like the study of very small things, like how does a positron relate to an electron? Those are really deep questions. But the thing is that these two theories can't like coexist with each other. The equations kind of break down, they disagree. So we've been trying to find like a unified theory of everything. And the reason why this relates to black holes is that the black hole cannot be described by our regular equations. We honestly don't know that much about black holes because we don't have the equation for it. Because the black hole is really dense, it has a lot of matter in it, so you'd want to use an Einstein gravity equation. But at the same time, it's very small. Like the very center point is very small, so you want to use quantum mechanics for that. So you can't really describe black hole, and that's why we don't know that much about it. But we know that they are necessary for keeping our galaxies in check. So, all right, guys, thanks.